Hey everyone, so I'm going to solve quadratic inequalities in this lesson. The first thing you want to do with quadratic inequalities is you do want to factor. So I'm going to do x and x, different signs. Factors of 54 that add to 3 are 9 and 6. We want a negative 3, so that's why I put the symbols where they were. So negative 9, positive 6 gets you a negative 3. You'll end up getting x equals negative 6 and x equals 9 after you set both equal to 0. And that's what goes on your number line. I'm going to give these open circles because this is less than, and then I'm going to pick values to test. So I'm going to test x equals negative 7, I'm going to test x equals 0, and I'm going to test x equals 10. Those are values that are in between here. And I want them all to be less than 0 because that's what my problem has, less than 0. Okay, so when I plug in negative 7 into my original or into my y equals, I end up getting positive 16, and positive 16 is not less than 0, so I will not shade here. But when I plug in 0, I actually end up getting negative 54. And negative 54 is less than 0, so I will shade here. But just to check, I'm going to do 10, and when I plug in 10, I get 16 again. And 16 is not less than 0, so I will not shade there. After you graph your number line, the last thing you need to do, and the most important thing you need to do, is state your solution set. In this case, x will live in the middle. So I'm going to put x. Negative 6 and 9 are your barrier numbers. You are going to need symbols now. Negative 6 is less than any x value that would be in here. So like it's less than 0. And x is less than 9. So for example, 0 is less than 9. So that's how you would state when the inequality is shaded in between two numbers. It is called the AND case because they are connected. The next question I'm also going to factor. The first thing I'm going to do is pull out a GCF of 2. And then I'm going to do AM. Factors of 15 that add to a negative 2 are a negative 5 and a positive 3. If you split this, set each piece equal to 0, you'll get x equals negative 3 and x equals 5. And that's what will go on your number line, negative 3 and 5. In this case, my circles will be closed because it is an equal to inequality. And I'm also going to pick test points. So I'm going to write test. I'm going to test x equals negative 4, x equals 0, and x equals 6. Because those are values that are in between here. In this specific one, we need them to be greater than or equal to 0, because that's what the original symbol was. So I'm just going to write that underneath my x value. I'm going to go to my y equals, and I'm going to type in the original problem, which was 2x squared minus 4x minus 30. And you can use that second math trick and put the inequality in, but I'm just going to find the values so you guys can really see why we're shading there. So for negative 4, I get 18. That is greater than 0, so I will shade over here. With 0, I get negative 30. That's not true. Negative 30 is not greater than 0, so I will not shade there. And with 6, I also get 18, so I will shade here. This is called an OR case because they're not connected. So what you do when you have an OR case with your final statement, you'll write the word OR, and x lives here, he lives over here. X is less than or equal to negative 3 for this problem, and x is greater than or equal to 5. So the way we say this is x is less than or equal to negative 3, or x is greater than or equal to 5.